Sorry, I forgot. Thanks.
Perfect. So today I'm going to talk a little bit about, I think you guys know the history. I've spoken at MonteVIDEO Tech Meetup before when I was in my role at Millicast as one of the executives at Millicast. And we got acquired back in February by Dolby Laboratories. And we are specifically working with Dolby IO, which is like the cloud division of Dolby. And one of the things we've really seen since last year is the immersion of 3D game engines being used to enable real-time immersive experiences with video and audio. And this is a very emerging space that I think is kind of defining, I think, what's going to be the future. If you read the book or seen the movie Ready Player One, I don't think we're too far off from a future being something similar to that, some dystopian future where maybe we get the most immersive human experiences through our devices, right? And how do we enable that? I'm not saying I'm a proponent of it. I'm saying that we're developing technology that enables it. So those are two different things. But I'll talk a little bit about some of the trends that I'm seeing in the industry. And Dolby is very invested in the gaming space. Obviously, there are leaders in audio and spatial audio globally and recognized as such, and also in video. And at Millicast, we've been focusing very specifically on real-time video. And unfortunately, my colleague, Paul Bosted, who's the VP of Product and Architecture at Dolby, wasn't able to join me, but he's an expert in spatial audio. And it would have been great to have him on the call. But he had an amazing talk at the RTC at Scale conference that happened earlier in the year that was put on by Meta, previously Facebook. And RTC at Scale is a very, very interesting concept. A year ago, I don't think anybody would have talked about RTC or real-time communication at scale. And now it seems like it's on everyone's lips, and everyone who's in the video or live streaming space is talking about real-time. So I'm going to focus a little bit on how these three pieces, 3D game engines, real-time video, and spatial audio, are creating the building block of this new thing that we're calling the metaverse. So what are we trying to do? And if you've seen any of my presentations before, and I've spoken previously, you've probably seen this slide before, but in the context of what we're trying to build with these building blocks, it's very true. Human nature is trying, it needs interaction. During COVID, we all craved it when we didn't have someone to go have a beer with or a live event to go and network at. We're talking about NAB and IBC, the streaming media conferences and so on. And it's very hard to actually push the boundaries of innovation when we don't have humans together. So how can we create the second best thing, which is doing it through the internet, which is built for this collaboration? Well, we need to build tools that enable human interaction and enable remote experiences and create this idea of virtual audiences. Not everyone can always make it to a live event. So what's the second best option is obviously attending it virtually, like I am today, and Adrian is today, and Robert is today, right? And we can still add value even in a remote environment. But what's really missing is okay, you're getting me in real time, but what other forms of human interaction can we really build into this experience? So this is one customer that we have. I don't think I've patched in my audio, but this is a customer of ours called Oz that are based in Iceland. And what they did, this is a great example of virtual engagement of remote audiences. Iceland is a country of only 300,000 people, and they wanted to bring in the new year this year using a social media platform that people could log into with their Bitmojis and be able to render those inside of Unreal Engine and have everyone bring in the new year together. During COVID, they had a lockdown in Iceland as well. But this is a way that they could all still really be part of the same community. So everything you're seeing here is rendered in Unreal Engine. They built in an integration with Snapchat and the Bitmoji in Snapchat. And you gave the permission to your avatar from Snapchat to be rendered inside of Unreal. And they created haptics, or they created kind of interactivity elements, like being able to throw confetti or being able to clap or do different things to have people feel a little bit like they have that interaction. So the company's name is Oz, and they also had another event shortly after for the launch of a premiere in Hollywood that also enabled that interactivity through Snapchat. So what do you need to enable this interactivity from a technology perspective? If you want interactivity, whether it's real-time one-way communication, two-way communication, or the ability to do clubhouse use cases where you have a passive listener who wants to become an active host, there's 4 components that are the building blocks of creating real-time. You need to be real-time. You need to be under a second, preferably under half a second. And in gaming use cases, more realistically, you need to be under 200 or 150 milliseconds to really create. If you think of a first-person shooter, right? Like I grew up with Doom and those first-person shooters. And when you look at that, you need no more than 100, 150 milliseconds, otherwise the experience doesn't feel real, right? And that's true of human interaction as well. We also need the quality to be something beyond web quality. We don't want a webcam, we want it to be broadcast quality. We want it to have spatial audio, so when we're in a 3D environment, we see a friend of ours who's approaching us, and as they approach us, we can hear them from the direction they're coming in, and their voice gets louder and louder and louder as they get close to us, right? The idea of spatial audio, especially as it relates to virtual events like live concerts and so on, is very key to creating this real-time experience and the interactivity we need. And then obviously we need web scale. I think we need a technology that can embrace the scalability of the internet and enable massive global audiences. The things we're trying to build, like for this event in Iceland, we're looking at several 100,000 people, but if we're all trying to experience the World Cup together, right? And Spain's going to be in the final this year, I guarantee you. Actually, maybe not, they're pretty terrible this year, but if they were, I'd want to experience that with everyone who's attending virtually, even people who haven't been able to travel to the venue. So we need a technology that can actually enable that massive global scale. And then security and encryption is always a very big concern. So all these things put together are really the prerequisites of trying to create a lot of the experiences that we're building. So we need sub-second latency. That's a feature, but what is the technology that actually enables this feature? And I won't spend too long on this slide because I'm sure all of you have seen this slide. This is a slide that was produced by Wowza many years ago. And everything on the left, you have common HTTP latencies like traditional Apple HLS or MPEG-. As HLS has become more optimized, you start getting into the under 10 seconds, 5 seconds. What we're really trying to do is replace what RTMP was doing just a couple of years ago. But even better than that, we're trying to now use a technology that doesn't require a third-party plugin. We're trying to use a technology that's native for the web. So if we're trying to do anything that's sub-second or sub-500 milliseconds, half a second, really there's only one technology that's built for this, and that's WebRTC. WebRTC is an IETF and W3C standard. It's supported by every major browser, every major mobile browser. It's available on over 1 billion devices around the world. And every device that gets launched today that says it's internet and web enabled has to have WebRTC in it. So if you're trying to stream a metaverse or a virtual event or some kind of gaming engine, and you're trying to stream that content to customers, you already have access to all of these devices without having to require an installation or a plugin or something differently, right? And that concept is a very new concept that WebRTC has enabled. So how do we get there? How do we do that? Well, Unreal Engine was very smart. They actually bought a company a couple of years ago called Pixel Streaming. And for those of you who don't know Unreal Engine, it's probably the world's most popular game engine. And it adds a lot of the features that you need to go and build your own game. So you can just work on the concept of the game and not necessarily work on the core C++ programming that you need to enable a lot of the features of that. So that game engine allows you to go to market very, very quickly. What's changed in just the last couple of years is that Unreal Engine is being used as the basis to go and build metaverse worlds or virtual worlds, whether that's for live concerts, whether that's for virtual events. There's a range of different use cases that are evolving from this very simple concept of having a game engine and being able to use a web-enabled technology to make that content be streamed around the world, or vice versa, capture real-time content from a camera, distribute through the web, and render it inside of a game engine. Both the streaming or both the publishing and the playback enabled through Unreal Engine is only something that's been around for the last year, a couple of years. And Unreal did that with a technology called Pixel Streaming. So pixel streaming is a plugin that you install into Unreal Engine. Unity is another game engine. I won't spend too much time talking about Unity, but they're also a very well-known game engine. Unity has this very similar plugin that allows them to do that. And they acquired a company called Furious that enables some of the same functionality with WebRTC. The problem with the pixel streaming plugin is that it's not built for scale. It's built to capture the render coming off of Unreal Engine of the video and the audio, but it's not built to actually distribute that and scale that across the internet. So that's kind of where we come in, right, at Millicast and at Dolby. We've been able to build a plugin that can grab the WebRTC content from Unreal Engine and scale that to the masses, and simultaneously also be able to capture live video and audio from a web browser like your camera and render it to a layer inside of Unreal Engine. So what does that look like? Well, it's always better to look at examples. So let's look at one example of a customer that's doing this. So we have a customer that's based in Los Angeles, and it's called Red Pill VR. And they're doing this with Unreal Engine. And this is an example of their use case, right? We're on the left, we've got the game engine content, but what's coming back is actually a live broadcast feed that they're streaming from their local computer. So simultaneously, you can stream the rendered 3D avatar, but you can also stream the DJ who's doing this virtual concert remotely and render that inside of the Unreal Engine game as well. So this is opening up a lot of very interesting metaverse use cases that you know, things like Coachella, right? Or Tomorrowland, I think that's happening next week in Belgium. Some of the biggest concert venues in the world. Not everyone can travel there, but how can we enable the workflows so other people virtually can actually experience in this? There's a very big event that happens at the end of August in the Nevada desert called Burning Man. And for many, many years, you know, it's difficult for people to make it at Burning Man, but how can you create a virtual experience that maybe resembles at least a little bit a lot of the experience you get live at Burning Man? I think we're just at the cusp of what this is enabling for these technology stacks. So I'm going to show a quick video here of our customer Red Pill VR and exactly what they're doing.
Imagine if Coachella, The Sims, and virtual reality were all morphed together.
And I don't know if you can actually hear the audio, but I'll share this after as well. But what the host is actually talking about is Coachella and everything else.
We're essentially building the future of social music experiences. We believe that music is
so what the chief magic officer at Red Pill is saying is they're trying to build the future of interactive experiences with concerts. So there's a virtual DJ here, there are virtual dancers. They're trying to do this all to really create a similar experience to what you would get in an actual live venue. The cool thing is you see some of these, the Furion balls here, they're actually fed from the base of the music that's being streamed from the DJ. So you can actually grab live audio from the DJ and patch that into a 3D model and have it react to the live bass that it's actually hearing.
Giant size dancer. Both were at the booth with me, injected
So
into the game.
you probably can't see this that well in Zoom because obviously the frame rate is not that great. So there's some very interesting things happening. Red Pill VR started in the local network environment. They were trying to enable this through a local network. But through our technology, they've been able to actually do this through the public web, which has made it, I think, so much more engaging, right, than having to be at a venue doing this. If you're going to go to a venue, why not just go to a concert? So
then I teleported to the VIP section where I was literally standing.
So let me go ahead and keep going. So the other piece to this too is we are enabling you to capture a webcam through your web browser, right? So this can be like kind of like Google Meet or like Zoom or like Teams or any other tool where you're capturing your webcam feed. But the reality now is what our customers are building. They're building virtual concerts. And if you're someone like Elton John, or you're someone like, you know, a very large artist, you're not going to want to capture your webcam. You want to capture professional broadcast content. So a lot of the things that we're trying to do is build in the tools, the video encoders that you need to be able to patch in a native WebRTC feed and do a lot higher encodings that can actually be rendered to a metaverse world. So this is just one example. This is a partner that we're working with called Osprey Video. They use GStreamer as their packager inside of Osprey, their talent encoder. And that packager, GStreamer, added WebRTC and WIP support inside of it. So you can actually stream from a live venue, capture the SDI, and then render that inside of Unreal Engine and get very good broadcast quality while still retaining half-second or second latency at the most with these workflows. And there's a lot of encoders we're working with that does that. So Teradek as well, with their Prism encoder, they're adding this. And then we have Bilbo on the call as well, who works for AJA. And with AJA, we've actually worked with another partner that you can use an AJA Kona card, capture the SDI content, and then you can stream it through our partner through WIP directly into Unreal Engine through Millicast as well. So really the story here is that we can actually do something that's way beyond web quality. We can actually do broadcast quality. So I'll show one more video of a customer, and then I'm going to actually pass it over to my colleague, Robert, who can talk a little bit more with a live demo about what we're doing. This is probably one of my favorite customers right now that's working with us at Dolby.io and at Millicast. They have built a metaverse world that's being used for live virtual events. So the name of the company is called MetaVerse, and I don't know if you guys have heard of them, but MetaVerse, they're based in Canada, but they're doing events all over the globe. They worked with Pepsi company, with AWS, with a lot of very large brands to help them with events like sales kickoff meetings. Every video that you see here, each avatar that has a face rendered into a 3D layer for their avatar is being pulled in through WebRTC. Here you see the actual webcams that are being showed, as well as the output render for other passive viewers who are maybe participating in the virtual event. These guys are definitely one of the market leaders in building virtual worlds that can be used to create real-time interactivity between human beings. So I think this is all extremely exciting. I think WebRTC is right at the heart of this. And it's really, in a strange way, bringing together these just different worlds, like the world of gaming, the world of video, have been kind of separated, and now they're really coming together. And what kind of finishes off that building block, especially as it relates to the metaverse and virtual worlds, is that we need to actually build spatial audio. Audio is so critical to creating the most believable human experience. So we're working on a lot of things with spatial audio. We have some basic spatial audio through multi-opus that we already support in inside of Millicast. But what we're working on is actually trying to figure out how we can use Dolby Atmos workflows potentially and build those into these exact workflows. We can replicate true human conversation through virtual experiences, which I think is very critical. Now, before I pass it over to Robert, one of the things I do want to point out, especially I talked about audio and spatial audio, but with video, one of the limitations we have right now with the Unreal Engine is that we can only use VP8 video. Unreal Engine hasn't been able to license or hasn't chosen to license H.264. So we're kind of using VP8 as the kind of fallback, for being able to enable the video coming out of these gaming engines. We're really hoping to push VP9. And then I know Adrian's going to talk about AV1. At Millicast, we're very invested in AV1. AV1 is supported by our platform, but these game engines still haven't actually adopted AV1, primarily because there's no hardware acceleration for it. So I could spend a whole nother presentation talking about hardware acceleration and what can be done with game engines. But the biggest trend, before I pass it on to the demo, the biggest trend is that I'm seeing is that all the heavy lifting that has to happen with Unreal Engine or with Unity as a game engine, none of that is running locally at the edge anymore for playback. The actual game engine is running in the cloud. So you have AWS, Google Cloud, Microsoft Azure, all the other major cloud vendors are all severely investing in the game space, because WebRTC has enabled for the thin client workflow where you can actually do the rendering in the cloud, but WebRTC can be delivered to a local client. So I'm seeing some very cool use cases as well for using an iPhone or a Samsung device or a mobile phone to control virtually an avatar that's actually being rendered off of different game engine elsewhere. So we're almost returning to the day of the 70s where we have a dumb terminal, which is the web browser, and WebRTC is enabling these workflows. So I think those use cases are very unique. And for those of us who have been in broadcast and streaming for many years, it's a departure from the days of having to control the entire media pipeline. Now we have to actually, I think, lend ourselves to internet-enabled workflows through WebRTC to be able to really push the boundaries of what can be done in this next generation. So with that, I will pass it over to Robert. Robert, I'll stop sharing my screen if you want to go ahead and show us a quick demo of Unreal Engine in real time.
Sure, thank you, Ryan. All right, so I'm going to share my screen. And it's probably not as compelling as seeing the Metaverse example, but this is our tutorial that you can also enable. Screen 2. You guys can all see my screen?
Yeah, that looks good.
So I'm currently using OBS to publish a stream with, and the codec I'm using is BP9. I don't have the audio up at this moment, but let me just get my mouse over here. Let me get my controller. And you can see basically with any conference or application, you can have your avatars in there and share a broadcast within Unreal Engine.
And what's happening behind the scenes here, Robert, is the actual video that you're seeing on screen is actually WebRTC video going through Millicast and being rendered to a 3D layer, right?
Yeah. So I also set up the other example at the same time. So you can also not only stream, you can basically stream to another player as well. Let me turn the audio back down. With that, another developer did set up an example with Babylon.js. So with Babylon.js, you can use the 3D mesh to render some spatial audio as well. So you can have and this could be like a watch party. You can have your friends sitting in the theater seats. If you move closer to the screen, of course, it's going to get louder. This is in like a 360 environment using Babylon.js. This is rendered in your browser, WebGL. That would be another example. Again, this is.
And Robert, what you have playing now as a source is something coming off of OBS Studio. Can you share your webcam as well as another source? We can see it live and see.
Oh, sure. Let me switch sources. Let me bring the meeting.
So while Robert's doing that, what's very cool about this is, I spent a lot of time talking about Unreal Engine. At Millicast, we developed for Unreal first. But we are working on a Unity SDK as well. And then there are a lot of other game engines that are very popular now. You also have Roblox, which is really becoming, if you have children who are teenagers or preteens, you've probably definitely heard of Roblox. So they're doing a lot of stuff as well to create virtual worlds.
So I'm now sharing my conferencing screen, and you can see everybody on the screen in here as well. And go back to Babylon as well.
And so if we all move, you can kind of see the difference between Zoom and the render inside of 3D. And exactly. There's a little bit of a delay because obviously we're not just streaming to a viewer, we're also then resharing through Zoom. So Zoom's being streamed 2 ways here. But that's a really cool demo, Robert. Well, the environment that we have here is just a default Unreal Engine project, but that's a way to get started. But people are building some incredible virtual environments for this kind of stuff. So that's pretty much our presentation. I am very excited about what's coming next. I'm also excited about other proprietary game engines. You think of Sony PlayStation and the Xbox, right, with Microsoft. And the games there, there's a lot of virtual experiences that could be built or watch parties that could be built into those game experiences. And I think WebRTC is at the center of that journey. So it'd be interesting to see what's coming out of this in the next few years, not just with Metaverse use cases, but like I mentioned, virtual events, virtual audience use cases and things like that as well. So with that, we'll open it up to questions for Robert and I.
Awesome. Thank you so much first.
Thank you.
Emil, I don't know if anyone down there has any question or anyone in the audience that wants to unmute yourselves, guys.
Don't be shy.
I will
Not the
say
pronoun.
we're not the only ones who are building, like this has been very focused on Millicast and Dolby IO. So a lot of other people building tools around this. You know, Agora has built some plugins too. I know Unity had bought a company called Furious. And the cool thing about Furious is their WebRTC stack, we've heard from customers, maybe isn't the best, but what they're doing is they're actually adding the virtual machine layer inside of an API. So with what that means is that just with one API, you can spin up a virtual machine running Unity or Unreal, in addition to having the WebRTC video output and audio output, which is I think that's a very cool thing. I wouldn't be surprised if Amazon Web Services comes out with a product like that in the next year, because that just takes it to a whole nother level. You don't have to be a video architect and know how to actually spin up, you know, GPU-enabled machines with Unreal Engine, you know, all that. You can use one simple API to do that. The other quick trend too, and I know we have similar friends at Xilinx and AMD, you have a lot of FPGA and manufacturers who are very focused on this market. They're trying to build custom-built hardware for the gaming and video industries. So what we've been using, the whole cloud thing that we've all been using for the last 10 years, it's general purpose virtual machines. What's really going to be amazing, and Simon might touch on this after, is, or sorry, Adrian might touch on this after, is when we start getting into purpose-built cloud machines that can actually do hardware acceleration for the things we care about, not necessarily general purpose, but very specific use cases and tasks. So with that, I think that's a good segue into AV1. We're big fans of AV1, so I'm excited to hear what comes up next.
Thanks, Ryan. And I'm pretty sure there are people trying to build AV1 hardware acceleration.
Hey,
yeah,
Ryan.
I mean, there's some support for it already. It just hasn't had a ton of adoption. There's some projects out there, just none of it has really made it to market yet.
Okay. Hey, Ryan, I have a question. Thank you for your presentation. It was great. My question is, what do you think are the biggest limitations right now?
We don't hear you well.
Okay. I have to speak louder?
Yeah, that's good.
Okay. What are right now the biggest limitations that WebRTC is having to achieve, like, all these goals you were proposing? Like, if we want to have a real experience right now in a concert, or what are the things that are limiting us to create those things? Is the software applications that are not ready yet? Is the WebRTC protocol needs something else to be achieved? Or do you think everything's ready to create those kind of things?
Yeah, that's a great question. So, I mean, WebRTC is a standard, right? So there are hundreds, if not thousands, of people involved in the working group that drives WebRTC. Anyone can go out there and build on it and build support for it, and then tell IETF or W3C to go adopt it. But a good example is, let's say we want to try to build Dolby Atmos support inside of WebRTC, and they'd be a supported standard. It's not as simple as just doing the tech work. We actually have to go and lobby, right, the IETF, and try to build it in so that all web browsers will adopt it. So it's the right approach, though, because I think where the internet's gone wrong, and we've learned this over the last 30, 40 years of the internet, is people trying to push proprietary workflows. Nobody wants that. We also, it's obvious that the internet and the web browser is the primary way we're all going to communicate from here to the future. So, you know, Zoom workflows, well, Zoom controls that, right? And they might shut me down right now, so I shouldn't say anything bad. But the nice thing about using the web browser is that everyone plays on the same playing field. So Creating standards can take longer because there's so many people who are contributing. Like WebRTC is used just as much with web-based virtual conferencing software as it is with what we're trying to build. So it means that it takes longer for standards to be adopted for things like spatial audio, which isn't a huge concern for maybe most WebRTC use cases. I think primarily, especially as we look, it's time for us to adopt newer video codecs. I think scalable video coding is the next generation of video codecs. And H.265 has such a complicated licensing model that it's pausing the adoption of SVC, which comes by default with AV1. I think the quicker we can get AV1 built into hardware accelerated devices, or have hardware acceleration support for that, AV1 is going to take over the world. I think it's going to be an amazing technology because it's going to take video to a whole new layer, a whole new level and layer. So I think those are the main things. I think it's just building video and audio codec support and making sure we don't do it with a proprietary workflow. We do it with standards.
Okay, thank you. I see like IP protocol took a lot of years to get common consensus everywhere. The same happened with HTTP and all the protocols you're mentioning. So getting a common consensus like in WebRTC would be like the next step. Thank you.
Thanks, guys.
Excellent. Okay, thanks, Ryan. Let's give it now the chance for Adrian to talk, and maybe we have more questions at the end.
Cool. Can everyone hear me?
Yes.
Sensational. Good to be with you guys. Am I between you and beer by any chance?
Yes.
Yes. All right. I'll try and keep it short and concise because nobody likes to miss out with beer. You can see my screen. Yep.
Not for me, Adrian. It's almost 1 in the morning here, so I'm good.
For me, it's 8:40 in the morning. So yeah, I'm on coffee. So so great to be with you. Thank you, JP, for the invite. Ryan, that was sensational. Beautiful segues into some of the things that hopefully I can share over the next maybe 20 minutes or so. I'm Adrian from Bitmovin. I'm located in Asia Pacific. One of my colleagues, Mateus, is on the call with us here. We've got a few people in your region, and I'll put the contact details up at the end. What I'm going to share with you now is just some feedback, some data that we've collected from our initial customers who are running AV1 in production. There are good and there are some bad sides, but let's try and make it interactive. So if anyone has any questions, jump in, because as Ryan said, this is very much an evolving topic. Let's start by kind of setting the scene. So this beautiful man, who I'm not even going to try and pronounce his name, but he's so important that he must talk with 2 microphones. Let's just call him Giselle. So in 1995, Giselle was part of the team that formed HEVC, or started forming the standards around the HEVC codec. So Giselle pioneered an approach. I'm thinking probably half the room know where I'm going with this, but let's just play kind of catch up for the other half of the room. So essentially, he wanted to represent how well his codec, his HEVC codec, was doing in terms of a graph that he could show performance tuning on. And the reason I'm slowly going through this is this will become very important as I go through the AV1 journey with you guys over the next 15 or 20 minutes, because this graph becomes kind of our way of defining success or failure. So on the vertical is quality. So in Giselle's time, it was PSNR. But I'm going to be talking VMAF because it's just evolved into VMAF being the vertical quality. Along the horizontal is bitrate. And the important thing to know about bitrate is the more that it is to the right-hand side, the more expensive it is going to cost you. So if you are trying to get a defined quality out at a bitrate of here, it's going to be this much CDN, this much storage. But if you manage to compress it 10%, 20%, 30%, 40%. That's less money you're paying with your CDN partners. That's quicker response time you're going to be getting from browsers starting the playback. That's less you're going to be spending on storage, less data you're going to be moving around, but keeping a very careful eye on the quality, because obviously what we want to do here is maintain awesome quality for all of our viewers. So that forms what we call the convex hull. And again, half the room know what a convex hull is, but for those that don't, it's effectively the optimum path of how quality and bitrate distribute themselves over the adaptive bitrate ladder. So as you're moving your browser, or as your playback is moving from 240p all the way up to 4K, you're effectively always trying to follow this gentle convex hull, so that as the browser jumps up its rendition ladder, you are doing it in a way that is optimized for both not overdoing your quality, but not overdoing your bitrate. There is a ceiling at the top of quality. So VMAF 9192 is where you're at a quality where you are no visually better or worse than the original, than the mezzanine content. So you can also over encode these things. So at any point in time, if you see the VMAF going above this pinky line, you're wasting energy, you're wasting encoding power, you're effectively over encoding it because a human eye can't tell the difference. So all the way through this, I'm going to be talking about this convex hull, BD graphs, bitrate along the bottom, quality along the top. All right, let's take a small step back. So AV1's been a bit of a journey for us at Bitmovin. So for those that are around the industry in 2017, we started spruiking it. It really wasn't ready in 2017, and in fact it's taken all of these years to get it to a point where we can call it in the wild or ready for production or in production with a subset of customers. So for us to have a codec that is ready for production, we have to take it through a few different stages. So first of all, the Bitmovin product, for those that aren't aware, is a cloud-based encoder. We also have a playback system that works on a myriad of devices, and we also have a data analytics tool. But primarily in the encoding space, it has to be multi-cloud. So we have to be able to run the encode process in AWS or GCP or Azure. We have to be able to control it using our tenancy or the customer's tenancy, and we have an entire API framework that is consistent across any codec that you subscribe to from Bitmovin. So effectively, the same control layer that you would use to make an HEVC encode, or a 264 encode, or a VP8 encode, or a VP9 encode has to feel and smell the same as when you do a AV1 encode. With that comes our ability to scale. So we don't want to have something in production that can't tolerate the types of extreme load that we see today by our production customers. I mean, we're talking some of the largest brands, some of the largest media brands, most well-known media brands in the world are relying on our technology to scale with them as they require more and more encodes to happen in parallel. We need that party trick to work with AV1 to be truly in the wild, and it's taken us a hell of a journey to make sure that the optimizing that happens inside the encode process can be tolerated for this kind of scale and explosion and growth. With that obviously comes reliability. You know, we kind of pride ourselves on the fact that encodes rarely fail, and typically they're failing because underlying cloud regions are going down or storage regions are going down, and hence why we always kind of run multiple encode regions, or a customer can choose to run multiple encode regions. So our reliability has to be there, and again, that's also part of this AV1 journey, that we needed the reliability and the repeatability to be present, so that whenever anyone asks for this codec, it behaves the same as all our other codecs. Yeah, Ryan touched on a hot point. So device support for AV1. I've got a few slides looking at our current state of the ocean here. Device for AV1 is an evolving conversation. It's not terribly great at this moment in time, but I'll get to that slide in a bit. Playback side is infinitely better than compression side at the acquisition end. So we'll look at all the devices that are capable of AV1 and believable of AV1 with DRM and with the other things plugged in, and we'll kind of present a bit of a table. but it's kind of like a 40% devices at the moment are tolerating it, with a big exception that our friends at Apple are not signing on for the reasons that they always go for. Efficiency. Now, efficiency is just a proxy for cost. So we don't want AV1 to be prohibitively expensive. It is more complicated to encode, so we do charge a small surcharge for encoding with AV1, but that surcharge is manageable now. So a lot of the time that's been spent over the last, 5 years has been performance tuning, optimizing, making sure that our use of compute resources is as efficient as possible as it relates to doing an AV1 encode. Ryan touched on that. I mean, this is performance tuning the virtual machines that we can get from AWS and Azure and GCP to make sure that the amount of machines that we have to run in parallel to do an encode, because ultimately when we encode, we split it out into every machine takes a GOP, and each machine runs that in parallel, and it recombines it at the far end. We call it split and stitch. But the amount of machines that we need to use for the amount of time, we need to optimize to keep the cost as under control as possible. And finally, and probably most importantly, is feature parity. So when you run an encode using Bitmovin, it has to be able to tolerate our content-aware technology. So basically, if you throw it a complex bit of content, think fast-moving movie action or moving water or sports or something like that, it defines the ladder up here. Hang on, I'm on a Zoom call. I have to do it over here. It defines the ladder as complex. But if it comes across a piece of content that is simple, like, for example, a cartoon, it will simplify the renditions, make the bitrate ladder low. That's our content-aware encoding. It helps move your ladder backwards and forwards depending on the complexity of what it sees. Has to be able to do the multi-pass. So the Bitmovin technology does 3 passes over a piece of content. If you turn that feature on, that just gets you a little bit more quality and it gets you a little bit more compression. But 3 pass has to be tolerated inside AV1. Our entire high dynamic range pipeline has to be possible. We're good friends with the guys at Dolby, so we were one of the first that worked with them on Atmos compression, Atmos spatial audio and the vision form of high dynamic range. But we've got other high dynamic range possibilities. And finally, we got a whole myriad of integrations with all kinds of different things that are all available in our GitHub repos and various bits of our website and on our community. All of these things have to also be compatible and tolerating across into the AV1 codec. So very long story short is it's taken us 5 years of talking about AV1 to actually come to a point now where we're comfortable that a customer can pick it up. And frankly, what I'm going to be talking about now is data from a very, very, very large, well-known global broadcaster, which I can't necessarily name, but it's a good one. So let's talk data. First of all, let's talk about some test content. So test number 1, we're going to do 3 tests as part of this speech or whatever it is I'm doing presentation. So test 1 is a 1080p asset skateboard. Now this bloke on the skateboard, quite fast moving action. Not particularly complex in the background, but there's a lot of kind of cut and changing going on. We're running the BD graph, so again, quality on the vertical, bitrate on the horizontal. We're running that in 2 different modes. So orange mode, H.264. So the 1080p rendition to hit a VMAF of 94.9, which is what we're calling excellent. Was done in 4.1 megabits per second. Run the same content for the same resolution for the same VMAF in AV1, and it's coming out at 1.4 megabits per second, which is a 66% saving, which is, to Ryan's point, fairly on the cusp of game changing there. If you're pushing stuff out in H.264 today and you mysteriously manage to get it all into AV1, which you won't be able to, but if that's your direction, you're talking about a 66% saving in your CDN and your storage, and all those devices that had narrow bandwidth that couldn't take up 4K or HD before, now mysteriously can. It's pretty cool. That's our first test then. BD graph for skateboard. So let's cover some more stats. So from a storage size, the original 264 asset was 160 plus meg. The AV1 asset was a 23 meg, so 62% saving there. So as you would expect, you got more compression, less bit rate, less bandwidth, less bit rate, less storage, saving for the same quality. Test 2, let's take it up a layer. So we're now talking about 4K content. Red Bull, who's one of our customers, did a collab with Samsung for the new Samsung 4K TVs. Well, they're probably slightly old now. So they made some highly complex test content. Now you can see a still from it there. So you basically got all these small particles moving around, lots of moving action. It's meant to show the quality of the TV and the responsiveness of the TV. So we're pushing this as very high complex asset and running the same equation with it. So to hit a VMAF of 93.3, 93-ish, the 264 encode was topping out at 8.6 megabits per second at 4K. Run the same game at AV1, it was a 3.6 meg, which is 58% saving. Again, it's consistent across both HD and 4K assets, as you would expect, but it is very, very good for the high complexity content as well. Test 3. There you go, 50% saving on storage. Test 3, but what about HEVC? So again, we took the skateboard asset, so this is an HD 1080p asset, and ran it through, in addition, an HEVC, an H.265 encode. So if you looked at the kind of original 264 size, HEVC took it down by 15%, so effectively kind of there, and AV1 took it down to kind of 66% down. So if it becomes a decision about whether you take your next jump, if you're a broadcaster, maybe it's this year, maybe it's next year, whenever you're doing your next jump, if it's a decision about, do I just jump to HEVC or do I jump to AV1? Well, on paper, AV1 gives you a lot of savings. Again, I'm going to cover the negative side in a second. Cool. Yeah, so 4.1, 3.5, 1.4 megabits per second. That's awesome. So, okay, you can save yourself a lot of bandwidth and a lot of storage size by encoding in AV1. That's goodness. Now let's go the other side of the line, the negative side of the line. And this is where it starts to get interesting, because I'm actually going to try and present a break-even point. We've worked with this broadcaster, and I'll explain why we have a break-even point and what the break-even point actually means. So let's start with the device footprint. So about 40% of devices-ish are tolerating of AV1 playback. And by tolerating, I mean it doesn't go red hot. You get more than 30 seconds battery life. It is somewhat hardware enhanced. The ones with ticks are fine. The first column is probably the important column, because as you appreciate, as you move into the right-hand columns, you're actually talking more about DRM support. So today, DRM is a mixed bag. Some devices support certain flavors of DRM. Widevine's very popular on the WebOS TV, smart TV devices, Chromes, all that kind of stuff. You've got Fairplay, PlayReady, and they've all got their subset of hardware that they have friends with, and you have some kind of overlap. But let's look at the left-hand column more in this situation. So at the moment, the ones with little stars is where the Bitmovin team's actively working with the hardware vendor. So today, things like the Roku stick do not have AV1 support. However, that is a work in progress with us kind of helping the hardware guys along. Ditto with our friends at LG. So the WebOS 2020 cannot support AV1 today, even though arguably the hardware can, it's more the operating system cannot. And again, that's some work that we're doing in conjunction. So the way I present this is today it's about 40%, but I think it's changing, and I think it's changing rapidly. Obviously the world of Apple, iOS, Safari, they're always going to try and pick the VVC consortium, which we'll talk about in a few minutes. But from an AV1 perspective, the device support is understood, not great, not bad, but enough that we can calculate a break-even point in a few seconds. So complexity was the next of our negatives, right? So if you spent the last few years building a 264 pipeline, the thought of changing your codec, all the quality control you've got to do, all the code changes you've got to do, can be quite daunting. Again, just re-emphasizing that at Bitmovin, we spend a lot of energy trying to make these things portable. So, for example, the 264 initiation code inside Python looks like that thing at the top there. So you're effectively doing an import of the 264 video configuration object, and you're running the API call for 264. If you do that with AV1, it's intuitively similar. So you're pulling the AV1 video configuration object, which behaves in the same way, and you're calling the AV1 endpoint. So in theory, the act of taking your current configuration, all the performance tuning that you've done, all the content aware settings that you've put in place, and carrying it to AV1 should, in theory, at least at a test bench, be a matter of a couple of extra code lines, a little bit of a fork, a little bit of a parallel, path. I say should because I would heavily recommend your QC team jumps in. You definitely want to have some people out there testing, making sure. When you start talking about dynamic ad insertion, when you start talking about high dynamic range, when you're messing around with multi-audio or spatial audio, there are things that can somewhat trip you up. But from a Bitmovin side point of view, we're trying to make it as easy as possible to port across. That was the Python example before. This is just our single API call example. So you can initiate a Bitmovin encode with a single API body, should we call it that? So in this case, if you change the body content from 264 to AV1, that is as much as you need to do to pull a standard ladder across. So this is the single API call encode approach for AV1, and that's available today. In fact, I'll kind of encourage all of you to go and have a trial of this, which is available on our website. Whenever you fancy. It's super easy. So we basically talked about 40% of the devices are kind of happy. We talked about kind of 60-ish% CDN saving. We talked about maybe storage for the AV1 slightly smaller, but you're going to have to put storage for the AV1 and storage for the 264 together to cover that 60% missing device footprint. So storage goes up a little bit, and Bitmovin is going to try and extract a little bit more money from you to do encoding in AV1. But when you put all of that into the mix, or certainly with this large broadcaster, when we put all of this into the mix, when they plugged in their CDN costs, when they plugged in their storage costs, when they plugged in the audience data, all of it bubbled down to this amazingly simple realization that any asset that they played more than 10,000 times, so any asset that their audience asked for more than 10,000 times, the break-even point for AV1 was triggered. And frankly, most of their assets were played more than 10,000 times because they've picked assets that were reasonably good and they have a huge audience. But that was the measure that they used as their kind of definition of how to do it. And they're a bit work in progress with this next aspect, but it's very conceivable that when you bring a new asset into the pipeline, you first of all do it in 264. And as it approaches the 10,000 view mark, you just trigger a supplementary encode to bring it up to AV1. The complexity of that might not be worth it. You might always be predicting you're over 10,000, so you might always be doing AV1. But it's an option there, if you want to consider it that way. So bottom line, 10,000 views. That's a simple way that we try to represent when it's useful to do AV1, any asset over 10,000 views. So that's me coming to the end. I'm about to invite you guys to drink beer together, and I'll have some coffee and breakfast. By a similar method, we've been spruiking VVC for 2 years now. VVC has got probably, honestly, another 2 years ahead of it. It is somewhat delayed. Bitmovin and the Fraunhofer Heinrich Hertz Institute work really closely together. That's actually a link to a joint paper that we did, and the Fraunhofer Institute is obviously the one that sits behind VVC. So we work together in consultation with our friends in academia, our friends at the Dash standard, and other industry parties to make sure that these codecs are done well. For those who are unaware, the history of Bitmovin is Stefan and Chris, who are our 2 founders, were also the founders of the MPEG-Dash standard. So at their university, their dissertation was commercialized to become MPEG-Dash in conjunction with a few others. And then Y Combinator came and jumped a load of money in, and that became a company. So that's basically the history of us. So we're always evolving, and we're always working on what we think is the future of video infrastructure, especially cloud-based video infrastructure. AV1 is very, very, very nearly ready for prime time. VVC coming very soon. And I'll just leave us with this slide to say, if you want to try AV1 today, right now, go to bitmovin.com, top right-hand corner, click on a trial. If you want to be part of the conversation, community.bitmovin.com, an active growing community. If you want to be part of the conversation the other way, we're in Video Dev Slack, #Bitmovin. Ping us up in there. We love the video community. So I was 2 nights ago at Sid Video, for example, with Jeremy. And it's really nice to be speaking to you guys across the other side of the world 2 days later. That's really cool. I'm Adrian at bitmovin.com. Your local sales in your region is Tadeo. There's his email address. Just a reminder on the left-hand side there that, I've been talking about Encoder, but we've also got a very valid player solution that works on a myriad of devices and a data analytics tool. And with that, I'll stop because I'm very nearly talking about sales pitch there. JP, back to you. I guess we might have some questions as well, right?
Totally. Thank you so much, Adrian.
Thanks, guys. Questions, or is it just drinks now? Am I stopping you from drinks?
No, questions first. They gotta earn them. So maybe you want to start sharing your screen so we can see each other.
Yeah, let's do that.
Thank you so much. So I'm gonna stop recording so we can, now